Hello students, welcome to the next topic for core maths, which is on linear relationships. And this topic will go for the next few weeks, all up to the end of the term. And today's lesson, we're going to start with a review of algebra, in that we probably need to know some principles in algebra in order to understand how linear relationships work. So before we get straight into it, I do want to list out some things that we'll probably be going over, and we'll look into the terms that are used in algebra, namely terms, coefficients, expressions, and equations. We'll also look into how do we combine these terms by adding and subtracting them, how to multiply and divide them as well. And then we'll look into factorizing and expanding your algebraic terms, as well as substituting the letters, which are called your variables, with numbers. Okay, so just a few things before we begin. When it comes to working with algebra, just as a bit of a recap on what you would have learnt in your previous years, okay, in algebra, letters, okay, are called variables. Okay, they're called variables, or they're referred to as variables. Okay, so the letters are referred to as variables. You could see something like X, Y, Z, or A. You could see B, C, maybe D. All of these are variables. Okay, and variables represent numbers. So the letters can represent numbers depending on the context of the question. Okay, X might represent 1, Z might represent 2, B might represent -3. Okay, really depends on what sort of question you're working with, but letters are referred to as your variables. Okay, also you'll come across terms such as these 7x. Now, in this case, when you see something like this, it means 7 times x. So in between the number and the variable, okay, there is a multiplication sign. Another example could be 5x. That means 5 times x. One more example, 7ab means 7 times A times B. Remember, the letters represent certain numbers. So 7AB means 7 times A times B. Okay, and in between a number and a letter, and also between two letters, okay, there is a multiplication sign. Alright, so just some things to keep in mind. Alright, let's get straight into it. Some keywords we'll use in algebra. Okay, the word term, okay, refers to something like these. Okay, so 5x is a term. 7x squared y is a term. 2a divided by 3 is a term. 7 is also a term. Okay, so when you come across a algebraic expression or an equation, okay, the numbers and letters that are together are terms. Letters that are by themselves are referred to as terms. A number by itself is a term, and you can think of a term as being split up by plus and minuses. Okay. Now, just really quickly, a constant term, okay, is basically a number that's by itself. Okay, a constant term is a number that is by itself. Next, coefficients. Okay, so coefficients are basically numbers that are in front of the letters. So in this little expression here, 7 minus 3x squared, the coefficient of x squared, so the number in front of 3, no, in front of the x squared, is -3. Okay, I'll just maybe underline that. So the coefficient of x squared is -3. Notice how I included that operator, okay, with that 3. If it's a plus, then you'll just call it 3. Okay, or if it's a positive, and you leave it as 3. So basically a coefficient, okay, think of it as number, okay, in front of letter, or in front of variable. Okay, so that is a coefficient, a number that is in front of the variable. And in this case here, 1 is a coefficient of y in this expression. Now, in front of any letter that is by itself, there is a magic number. It is the number 1. Okay, So in front of this y, there is a 1 in front of it. Alright, so just keep that in mind. Whenever you get a letter by itself, there is a number 1, which is the coefficient in front of it. Another quick example, you might see something like this. 3x minus z. Okay, so the coefficient of z is that magic 1 in front. Okay, but in this case, because there's a negative, okay, the coefficient is -1. Okay, is the coefficient of z there. Okay, so keep that in mind, please. Okay, next one, an expression. So basically, an expression is a set of variables and terms and coefficients all put together. Okay, so you could have this here is regarded as an expression. It means 7 times x. This is also a coefficient. Sorry, an expression. 3x plus 2xy. Okay, x plus 3 divided by 2 is also an expression. So you got to have some unknown variable, and then you could have other terms or other coefficients and other expressions that are also put together into one. This is also here a expression. Now the main thing to remember with expressions is there are no equal signs. Okay, just think of that. That's the basic understanding, or the basic way to put it is that a expression has no equal signs. Alright, so all expressions have no equal signs. I'll put that here. Expressions have no equal signs. Okay, keep that in mind, please. But an equation has an equal sign. Okay, generally with an equation, you'll be asked to solve or find the unknown, where it might ask you what is x, or figure out what x is. Okay, in this case, x equals 5. So an equation has an equal sign. In this case, 7x minus 1 equals 2. Okay, an equation has an equal sign. X squared plus 2x equals -4. Again, an equation has an equal sign. Just a little footnote note here. Expressions can be evaluated by substituting a value for each numeral. Another word is variable there. So remember, letter is also known as a variable. But what this is saying is you can actually figure out what the answer is for 7x if you can replace or change the letter or the variable or the pronumeral into a number. Okay, order of operations is also important. Okay, you may have seen this in other variables, but brackets, indices, multiplication or division. Okay, and then addition or subtraction. I think you may have seen the word before, bid mass. Okay, so brackets, indices, division, multiplication, addition, subtraction. Okay, just maybe revise on that if you have forgotten how to do that. Brackets, okay, indices, division, multiplication, addition, and subtraction. Okay, let's move on. Okay, like terms. So this is a term that you probably have seen before, but think of like terms. Short way of understanding it is when you have terms where the powers or the indices are exactly the same. So indices and the variables must be exactly the same. Okay, so the definition there is also quite useful. Like terms have the same pronumeral. Okay, so the same pronumeral part using addition and subtraction can be put together, can be collected to make a single term. Okay, so think of like terms as having the same letters and also powers or indices. For example, in this little equation, or actually this is actually, yeah, you could treat this as a, no, this is not an equation, this is an expression that's just being shorthand or made shorter, so made smaller. So in this case, the like terms here are 3x and -7x and also x, okay? And the reason why they're all like terms is their letters are exactly, or the variables are exactly the same. Don't worry too much about the numbers in the front, okay? But worry for like terms, you need to look into the letters being exactly the same. So the variables being exactly the same. The coefficients don't really matter. Although they do matter in that how you add them. Okay, but for like terms, look for the same letters to add together, or the same group of terms that are exactly the same. So in this case, you might think a squared b and ba squared are different, but they're actually the same. Okay, because whether you put the b in front or the b in the back, you still have an a squared and a single b. Okay, so they're still exactly the same if you think about it. And when you put them together, the thing that you have to look out for with these, with like terms, is what are you adding and what are you subtracting. Remember, in front of that lonely x is a magic 1. Yeah. So in this case, 3x minus 7x plus 1. So 3 minus 7 is negative 4 plus 1 will equal negative 3. Okay. 6a squared b, take away ba squared, is going to be, remember, in front of that b there is a magic 1, and, or a per numeral, a coefficient, sorry. So in this case, 6a squared b minus 1ba squared is going to be the same as 6 minus 1, which equals 5a squared b. Again, remember that whether you put the b in front or at the back for these equations, they're exactly the same. Or this expression is the same thing. Another example could be 2ab squared c plus 3cab squared. They're both exactly like terms, okay, because you can see that the a and the a have no power or no indices. The b squared, there's also a b squared there, so they both have squares, and the c is by itself as well. So whether you put them in different spots or in the same position, as long as they have the same variables and the same indices, it's fine. You can add them together. So when you add these two together, so 2 of these ab squared c plus 3cab squared is going to equal 5ab squared c. Okay, and just like I said before, now when you see 7x, where's my cursor? When you see 7x, it just means 7 times. Now when you see a line, a fraction line, remember it just means divide. So a lot of algebra is actually written in shorthand like this. So for example, if you see something like 6 times x times y divided by z, for example, okay, if you were to write this in shorthand, it would look like this: 6xy divided by z. Okay, or you might see something like this: 7 divided by a squared, okay, is going to actually look like 7 over a squared. All right, let's move on. So these are some extra things that actually you will need to know these ones. So distributive law is used to expand your brackets. Now, a lot of these, with these things that I'm explaining, we'll go through some examples later on to make sense of it. Okay, but distributive law, the key idea behind distributing is expanding your brackets. Now, you might see your questions in this form: expand the following expressions, for example, or expand the following equation to solve. Okay, but the idea behind distributive law is to expand your brackets. Okay, now in this, whenever you come across distributive, okay, what you're doing is you'll come across some brackets with a number on the outside, and all you have to do is you have to multiply the number on the outside with the number of the brackets inside. So this is going to be a times b, then a times c, a times b, and then a times c. And if you, when you work them out, it'll become this. So it's going to be a times b plus a times c, ab times plus ac. Oh, this one is going to be ab minus ac. So for this one, it's going to be 2 times x plus 2 times 7. So 2 times x becomes 2x, right there. And then 2 times 7 becomes 14. I might use a bit of color to make sense of that. So 2 times x, you get 2x. Oops. And then for 2 times 7, okay, you get 14. Another example down there, negative x times 3 will give you negative 3x. Either negative x times negative x gives you a positive x squared. Notice how when you actually multiply variables together, that the indices or the powers actually get added. Okay, so for example, you might get something like this: x times x will equal x squared, because these both have little ones on top. But if I had something like x to the power of 2 times x to the power of 4, looks like a 9 of 4, okay, it's going to be x to the power of, now see the indices, 2 plus 4 will equal 6. Okay, or x to the power of 1 times x to the power of 7. Now generally you won't see that 1 there, it'll actually be rubbed out. Okay, so you'll see x times x to the power of 7 will become x to the power of 8. Okay, so keep that in mind when you're multiplying indices together, you're multiplying variables, you have to add the indices. Now the other part, or the other side of, or the opposite of expanding brackets is to actually factorize. Okay, so these here are expanded. So these, you could call these, your expressions are expanded, but to factorize means to put it back into the bracket form like this. Okay, so to put it back, to factorize means to put the expressed or the expanded answer back into bracket form. Okay, so making expressions as a product of factors, basically putting it back into bracket form. Many expressions can be factorized by taking out the HCF. Now you probably haven't seen this in a while, but the highest common factor. So you'll need to be good at multiplying and dividing, mainly dividing for HCF when it comes to doing factorizing. Okay, so in this case, if you wanted to factorize the number 15, you could split that up into 3 times 5. Okay, because 3 times 5 equals 15, or you could also do 1 times 15. That works as well. If you wanted to factorize 3x minus 12, okay, well the common factor for 3x and negative 12 is the number 3. So you'll have to divide the whole thing by 3. So if you were to factorize it, it would look like this: 3x minus 12. Okay, and if the common factor is 3, you'll have to divide all of them by 3. So in this case, the final answer will be, putting it back into bracket form, x minus 4, right there. Okay, because if you were to expand this, it'll become 3x minus 12. And here, factorizing this, will 9x squared minus y minus 6xy plus 3x, okay, equals 3x, bracket 3xy minus 2y plus 1. This one might take a bit of time explaining, but we'll probably do it a little bit later when we get to a question where you're asked to factorize something like that. Okay, let's move on. Just really quickly, these things you won't really need to know too much about. Okay, but you will probably come across it later in year 11 or year 12. Okay, but think of associative as when it doesn't matter where the brackets are. Okay, but you do have to do the brackets first. But regardless, what this is saying is whether you put the brackets up here in the front or in the back and you work it out, you're going to get the same exact answer. Okay, same with, but that's only with if all of them are multiplying. So if all your numbers are being multiplied. If they're being added as well, it's the same thing. Okay, for commutative, this is saying that whether you put A or B at the front, or whether you multiply with this number first and the other one second, it means the same exact thing. Same with addition. Okay, so whether you add A first or you add B second, okay, or you add B first and A second, it's going to be exactly the same thing. Just note that A over B, so when it comes to a fraction, A over B does not equal B over A. So what that means, okay, is basically if you have 7 divided by 2, does not equal 2 divided by 7. Okay, because they're going to be different answers. Same with, say for example, if a was, let's say 6 minus 3, so let's call that a, this is b. This does not equal the same as 3 minus 6, okay? Because 6 minus 3 is 3, but 3 minus 6 is negative 3. Identity, just think of that as when you multiply a variable with 1, okay, you get the same exact variable back. Or when you add a variable to 0, you still get the same variable. And inverse is the opposite, or I would think of it as the opposite of that variable. Opposite of times a would be divided by a, and the opposite of plus a would be minus a, or negative a. Okay, so these things you don't really need to know too much about. We'll go over it in a little bit more detail next year. Okay, now let's go through some actual examples to make sense of everything that I have just mentioned. Okay, so for these examples here, let's go through some of them to actually make sense of what I'm actually talking about and what I'm explaining here. Okay, so which one of these is an equation? Remember, an equation has to have an equal sign. Okay, it must have an equal sign. So right there and now I can see that A doesn't have an equal sign, so it can't be that. Also cannot be B, it's no equal sign. C has an equal sign right there, so it must be C. And yep, D doesn't have an equal sign, so it can't be that one. Okay, which of the following expressions, remember an expression is basically a group of terms, so whether they're variables or numbers by themselves, like constants, that's an expression just put together. Which expressions contain a term with a coefficient of -9? So which of these expressions has a term that has a coefficient? So remember, a coefficient is referring to the number in front of a letter or in front of a variable. So it has to be -9. Well, let's have a look. 8 plus 9x, well, there's no -9 there, so that doesn't work. 2x plus 2x, 9x squared plus y. Again, no -9 there. C, 9a minus 2ab squared, sorry. There is negative, but it's not with the 9, so it can't be that. So in this case, it's this one here. This term here has a -9. So a squared has a coefficient of -9. So it's this term. 9a squared. Okay, this term has a coefficient of -9. Oh, that expression, sorry. Alright, next one. State the coefficient of a squared in these expressions. So what is the number in front of a squared for these expressions? Well, let's have a look. For a squared here, remember, if you just have a variable by itself, that means there's a magic 1 there. So that means the coefficient for a here is 1. Okay, here is pretty easy. Coefficient, so the number in front of a squared is -4. Don't forget to include that operator. Now these ones are a bit tricky. Okay, a squared divided by 5, or -a squared divided by 5. Now remember, in front of every single letter by itself, there is actually a 1. However, when you see a fraction like this, it can actually be represented as -1 over 5. Let me fix that up. -1 over 5 times a squared. So the number in front of a squared is actually -1 over 5. So this here, okay, is the coefficient of a squared, -1 over 5. Okay, and by the same principle, okay, this term here can be represented as -7 over 3 times a squared. So the coefficient in front of a squared is -7 over 3. Okay, that's my coefficient. Alright, next part, decide whether the following pairs are like terms. Okay, so remember a like term is basically where both or all the letters in those terms are exactly the same. Okay, so xy and 2xy are definitely like terms. And if you were to evaluate it, actually it doesn't say plus and minus, so let's leave it at that. Xy and 2xy are like terms, definitely like terms. 7a squared and negative 7ab. Okay, so making sure again that the letters and the letters are exactly the same and the indices as well. So a has to have a squared, which it does, and b just is to the power of 1. So yep, these guys are like terms. Negative 4ab squared and 8ab squared c. So remember the numbers or the indices of those variables must be the same. So a and a are the same, but b and b squared here not the same. Okay, so that, and c squared, okay, there's a c squared here, but c doesn't have a squared here, it's missing. Okay, so not like terms for that one. Evaluating these really quickly again, you don't really need to do these in your 10, but we will go through them. So negative 3 in brackets to the power of 2 is basically, say, negative 3 times negative 3. The squared, remember, all these indices refers to the number of times you're multiplying that number to itself. So negative 3 times negative 3 is positive 9. Okay, this one here, negative 2 to the power of 3 is basically saying, I should use the brackets, negative 2 times negative 2 times negative 2, 3 times. So that would be negative 2 times negative 2 is positive 4 times negative 2 will give you negative 8. Okay, now these ones are a bit trickier when you have a negative without the brackets, but let me just split that up. Okay, what this is saying is basically in front of that 2 is a negative 1. So it has to be negative 1 times, okay, that 2, I'm just going to split that, to the power of 3. So times 2 times 2 times 2. So there's a negative 1 in there. So basically when you see a question like this, you can already assume, okay, that the answer is going to be a negative, okay, because there's a negative 1 in front of it. So in this case, it's going to be 2 times 2 times 4 is 8 times a negative 1 gives you negative 8. Same principle with this, okay? So there's a negative 1 in front of that 3. So it's negative 1 times 3 times 3. Now I wrote times 3 twice because it's 3 squared. So that will equal 3 times 3 is 9 times negative 1 gives you negative 9. Okay, let's go through some actual examples that you'll probably use for in the textbook when you do the questions. So simplifying by collecting the like terms. So remember, like terms, okay, refers to the letters and the indices of those letters being exactly the same. So 7a plus 3a, so 7 of the a's plus 3 of the a's will equal 10a. Easy. 3a squared plus minus 2a squared b, or 3a squared b minus 2a squared b. They're in exactly the same position already, and all the variables have the same indices, so I can assume that they're like terms. So 3 minus 2 will equal 1a squared b. Now remember, when there's a 1 like this in front of the a squared b, you can actually just leave it as a squared b. Okay, you don't have to put that 1 in there. Yeah, put the like terms together here. 5xy plus 2xy squared minus 2xy plus 3y squared x. Okay, now this has 4 terms here now, which can get a little bit complicating, but again, just look out for the like terms. I'm going to circle them for you. 5xy. Okay, are there any other xy's here? So remember, same variable, same indices. I can see that negative 2xy is a like term. Okay, that's 1. What are the other like terms? What about for positive 2xy squared? Do we have any of the other two xy squareds? Well, in this case, this one is a like term, y squared and x. Even though they're in different order, or written differently, they are still like terms. So when I put them together, put those two together, and I put these two together with one color. So in this case, 5xy minus 2xy equals 3xy. Okay, and then you're left with plus 2xy squared plus 2y squared x. So adding them together, 2 plus 3 equals 5xy squared. Okay, so put the like terms together. Oh, actually, I'll do that in another color so you guys can get it. So 5xy to xy squared. Okay, let's move on. Next example, simplifying these. Okay, to simplify these means to just multiply them together. Okay, to simplify these terms means to just multiply them together. Now, whenever you're multiplying variables, when you're multiplying terms like this, okay, remember that you multiply the numbers and you add the letters together. Okay, depending on what the powers are. So in this case, 2 and 7, if you multiply them, will become 14. And then all you have left over are H and L. But remember, you don't add you can only add together the letters that are the same. H and L you can't add, so you're left with H, L. Okay, 14HL for that one. Over here, what you'll be doing is it's negative 3p squared r times 2pr. Okay, so what you want to do here is the numbers or the coefficients you're going to multiply together. So negative 3 times 2. But the variables, okay, so the p squared, so the p squared and the p are going to be added together. And then the r is also going to be added together, but in terms of the indices. Okay, so let's work this out. So the p squared, the 3 and the 2. So the negative 3 times negative 2 will give you negative 6. Now the variable p squared times p. So if you go p squared times p, remember there's a 1 on top of that p. So you just add the p's together, or the indices together, and you get p to the power of 3. And then the r's, okay, it's r to the power of 1 times r to the power of 1 will give you r squared. All right, so there's your answer there. Now when it comes to dividing, okay, you're more or less doing the same thing. So the coefficients get divided, but instead of adding the variable indices, the indices of the variables, you're actually cancelling or minusing them. Okay, so in this case, negative 7xy divided by 14y, well, 7 divided by 14, okay, is the same as a half. So you're left with negative 1 over 2 for now. Now the x and the y, depending again on what the variable indices are, okay, they get cancelled out. So one y, take away another y, will give you no y's left. All you're left with is the x. Okay, so there's the 1x, negative 1x over 2. Now remember, whenever you have a 1 like this, you can actually represent it as just, or if you have a variable where there's just a 1 in front of it, it's just going to be x over 2. So negative x over 2 for that one. All right, let me pause it there, and I'll get you guys to just start working on questions 1, 2, and 3 from your chapter 1A. All right, so pause the video, work on questions 1, 2, and 3 from chapter 1A. If you need the textbook, they're right there. All right, or ask your teacher, please. Thank you. Okay, expanding using the distributive law, and then simplify, or in other words, put the like terms where possible for these. Okay, so let's expand them. Remember, the distributive law is all about multiplying the number on the outside with the number on the inside. Okay, so in this case, 2x is going to be 2 times x, so that's 2x. Let's clean that up a bit. So 2x. And then 2 times 4 is going to be plus 8, because 2 times 4 is 8. Okay, in this case here, negative 3x times x. Okay, that's the first one. And then also negative 3x times negative y. Okay, let's do the first one. Negative 3x times x is going to give you negative 3x squared. So remember, when you're multiplying any variables together, the indices must get added. So in front of these, on top of these x's, there's a power of 1s, and you add them together, you multiply them together. And the next one, negative 3 times negative y. Remember, negative and a negative will give you a positive. Okay, so negative times negative is a positive, and then 3, and then the xy. You can't add the variables together because they're both different variables, so you leave them as like this. This one here, okay, this one is exactly the same thing, except now you're going to do it twice, and then you're probably going to have to simplify them. So let's do these together. 3 times x is the first one. 3 times 2 is the second one. So 3 times x will give you 3x plus 3 times 2 is 6. Take away. 4 times 2 is negative 8x. So there's your negative 8x, and then negative 4. So I've done this times this as well. So negative 4 times 2. Negative 4 times 2x is negative 8x, and then negative 4 times negative 4. So if you put the two negatives together, it becomes plus 16. Okay, now from there, remember, it says to simplify as well. So let's simplify these, as in putting the like terms together. So I can see that 3x and negative 8x are like terms, so they will be put together. And then you've also got positive 6x plus the positive 16. They're like terms, so let's put them together. So in this case, 3x plus minus 8x will give you negative, negative 5x. Okay, 3 minus 8 is negative 5. And then 6 plus the 16 will give you 22. Okay, let's move on to factorizing. Okay, this one might be a little bit trickier, but the idea, remember, of factorizing is to go from you expanding the brackets back into the bracket form. Okay, so putting things back, or putting expressions back into the bracket form. So what you'll need to understand is trying to figure out, or trying to remember, what are factors that go and can be divided into the numbers that you've been given, or into the terms that you have here. So the highest common factor for 3 and 9, so the number that can be divided into 3x and negative 9 would be the number 3. You can divide 3 by 3, and you can divide negative 9 by 3. So if that's the case, okay, that number 3 will go on the outside, okay, and then the numbers on the inside, well, that's the numbers that you'll be dividing by, or the numbers that you've divided by, and that's the answer to it. So 3x divided by 3, so for this one, 3x divided by 3, so that first one there is going to be x. So 3x divided by 3 for that first one. Okay, we'll cancel out. You're left with x. And the next one, okay, is negative 9 divided by 3. So negative 9 divided by 3. Well, if you think about it, 3 goes into negative 9 3 times. So all you're left with is negative 3. Okay, so it's 3 times 3x, 3 times x minus 3 is the factorized form of this. Let's try this one. So 2x squared plus 4x. Okay, what's the highest common factor between 2x squared and 4x? Now, you can start by thinking, yep, 2 can be divided by 2, and 4 can also be divided by 2. Okay, but then don't also forget the x's. In this case, x is the highest common factor of x and x squared, because you can divide x squared with x as well. Okay, so in this case, 2x is the highest common factor. So 2x squared divided by 2x Okay, for this one, well, basically the 2's cancel out, and then the x, and there's a 1 here with the x, so now that becomes 2 minus 1, and you're just left with the x. So here you start off with x plus, okay, now 4x divided by 2x, so 4x divided by 2x, so that would be 4 and 2 gone. X divided by x, you're left basically with, oh sorry, that gives you 2. X divided by x cancels out, so you're left with 2. So 2x and x plus 2. Last one here. Evaluate a squared minus 2bc if a equals negative 3, b equals 5, and c equals negative 1. So by evaluating this, what it's saying is just substitute the letters with the given numbers. So a becomes 3, b becomes 5, and c becomes negative 1. So if that's the case, a squared is going to be negative 3 times negative 3. Take away 2bc, so 2 times b times c, and that will become, so take away, so 2 times b, which is 5, times c, which is negative 1. So evaluating that, so what you want to do is evaluate them like this. So BODMAS, or BIDMAS, sorry. Negative 3 times negative 3 will give you positive 9. Take away 2 times 5 times negative 1. Well, 2 times 5 is 10, times negative 1 is negative 10. Okay, negative and negative will become a positive. So that negative 10, okay, now becomes a positive 10 because there's 2 negatives there. So 9 plus 10 is equal to 19. Okay, and I believe that's it for this chapter. Go on and do the rest of chapter 1A. Alright, the exercises are in your checklist over here. Also, just a heads up, if you need the questions, so we are now using the new textbook, no longer the old one. Here is a copy of that textbook. Okay, so you'll find that in your notes, or please go ask from your teacher to give you a copy of the questions for chapter 1A to 1G.